Hello everybody and welcome. I hope you're all doing well. I myself am doing fine. And I thought it was about time we started a new contest paper to go through. So we've chosen for us the 2005 Friar Contest. That's the 2005 grade 9 competition. And it's the written competition, not the multiple choice Pascal competition. This is the one where you need written solutions, justify your answers, and it's nice little practice for the Galois and Hypatia, which come later, and of course the Euclid, which is a very important but grade 12 or 12th grade contest. And there'll be other videos for those things. But we're going to be looking at the 2005 Friar today. So let's take a look. 2005 Friar. It was written on Wednesday, April the 20th, 2005. Question number 1. Okay, it's got 3 parts, so we can just check that out right away. So, A part. 2 circles have the same center C. Circles that have the same center are called concentric. Okay, so that's basically like co meaning the same, centric meaning center, concentric. It could be called concentric, I guess. There's collinear as well, but concentric is the word. So they have the same center, they're concentric. The larger circle has radius 10. So that's this big one over here. And the smaller circle has radius 6. Determine the area of the ring between these 2 circles. Okay, not particularly difficult. What we need to do is realize that this smaller circle plus the ring is equal to the area of the bigger circle. And from there, we use the formula for the area of a circle. We should be able to get ourselves an answer. So we grab ourselves some paper and we get started. I like drawing a little bit of the picture. There's C. It's not the best picture, but it gets the job done. Right, we know what we're looking for. Okay, and so we've used black. Let's use another color. So this smaller radius is 6, and this larger radius is 10, which might be a little difficult to see. So the area of the big circle equals the area of the small circle plus the area of the ring. Okay, that's just an observation we can make. So rearranging, so we just rearrange this equation. We realize that to get the area of this ring in here, we just take the area of the big circle minus the area of the small circle. Okay. Area of the big circle, well, it's got radius 10. So we know pi r squared is the area of a circle. So pi r squared, well, the radius is 10. And we have to subtract off the area of the small circle. Well, the small circle has radius 6. So pi 6 squared. And now we can sort of realize, we can expand this out. So 10 squared, that's 100. So we have 100 pi. And then 6 squared, that's 36. So 36 pi. And we can work that out on our calculator if we so desired. So 100 minus 36, that's how many pi's we'll have. We get 64 pi as our final answer. That's the written contest, so rather than bubble something in, we're going to have to give a little statement. (64 pi), and I believe there were no units associated to this, but we'll double check. Right, radius 10, not 10 meters or 10 centimeters or anything like that. We've determined the area of the ring between these two circles, so we can move on. Okay, B part. In the diagram, the three concentric circles have radii of 4, 6, and 7. Which of the three regions, X, Y, or Z, has the largest area? Explain how you got your answer. Okay. So X is the small circle of radius 4. Y is the difference between the medium circle, whose radius is 6, and the small circle, whose radius is 4. And Z is the difference between the circle of radius 7 and the circle of radius 6. So all we need to do is calculate those three values and figure out which of the area is the largest. So X is the area of the small circle. It's going to be pi 4 squared, 16 pi. So 16 pi is what we're looking at right now. And I suspect that this next one's actually going to be the biggest, just trying to work it out in my head. Y is the area of medium circle. Minus the area of the small circle. Well, we already know what the area of the small circle is. That's 16 pi. But we can work it out again. So the area of the medium circle, that was radius of 6. So we got pi 6 squared minus pi 4 squared. Well, that's 36 pi minus 16 pi. That's going to be 20 pi. So Y is looking like it'll be the biggest area. Okay. And finally, Z. That's the area of the big circle minus the area of the medium circle. So the big circle, he had radius 7. And the small circle had radius 6, as we or sorry, not the small circle, the medium circle had radius 6 that we've already mentioned. So that's 49 pi minus 36 pi. We can sort of treat pi as though it were an x or something, like a variable, and that allows us to simplify, and we get 13 pi. So Y is the largest area. Pretty straightforward. We calculated each one of them in turn, X, Y, and Z, and we explained where they were coming from. X was the small circle, Y was the ring between the medium and the small circles, and Z is the ring between the big and medium circles. Used the area of a circle, calculated them all out, we just compared them. 20 pi is bigger than 16 pi, which is bigger than 13 pi. So Y is the biggest, Z is the smallest, and X is the one in the middle. Okay. Now there's a C part to this question, so we're going to need ourselves another piece of paper. And let's take a look at C part. Alright. 3 concentric circles are shown. The 2 largest circles have radii of 12 and 13. If the area of the ring between the 2 largest circles equals the area of the smallest circle, determine the radius of the smallest circle. Explain how you got your answer. Okay, well, right off the bat, my guess is that the radius is going to be 5, and I'll tell you why. So far, we've been using the formula pi r squared, so whatever the radius is, we're going to end up squaring it. The difference between the big circle and the small circle, well, that's the difference between the radii squared times pi. 13 and 12, I know these are part of a Pythagorean triple. 5, 12, 13. So 13 squared minus 12 squared should be 5 squared. And the pi comes along for the ride. Now, if you understood that, great, and you'll probably have similar reasoning, and you can, explain how you got the answer really quickly. If not, that's okay. Try these contests, and we don't have to know everything as we go into them. But let's explore, and I'm pretty sure the answer will be 5, but only a true justification will be able to show that for us. So let's take a look. Draw ourselves a little bit of a picture. Okay. You don't have to get out your compass and straight edge to do all this. You can just sort of eyeball it. The pictures are just for you. When you're drawing them on a contest, they're just for you. They're not to scale. Heck, the contests even give you diagrams that aren't to scale, so don't worry about the stuff in your notes being to scale. I've seen a lot of people just waste time trying to make their diagram look perfect, and that really doesn't matter. The point is that you've got everything there that you need in order to try and solve the problem. Give yourself a picture. It's just supposed to be an aid for yourself. The math, the algebra should speak for itself. All right. So we want the area of the ring to be the same as the area of the circle. That's what the question asks for us. The ring between the two largest circles equals the area of the smallest circle. Okay? So we want to figure out the area of the ring, because that'll tell us what we need to set the formula pi r squared equal to. So that's the difference between the area of the big circle and the area of the medium circle. Alright, we've done this before. Pi 13 squared minus pi 12 squared. Always remember we need to use that formula pi r squared, and we know the radius of the big one's 13. We know the radius of the medium one is 12 squared. We need to know the radius of that smallest square. That's what we're trying to figure out overall. Okay, so that's going to be 169 pi minus 144 pi. And that should be equal to 12 pi, but we can work it out on our calculator. We just take 169 minus 144, 25 pi. So we just double check as we're going along. We don't want to assume it's Pythagorean triples and rush ahead, but it is going to be Pythagorean triples. All right. So we know 25 is going to be pi r squared. So if we divide through by pi on both sides, we get 25 is r squared. So r equals 5. Somebody out there might be saying, can't r be negative 5? No, you can't have a negative radius. Radius is a length. And we have a little statement there at the end, thus the radius of the smallest circle is 5. And I think that's all we were asked for, but we just double check. Determine the radius of the smallest circle, there we go. We figured it out. First we calculated the area of that ring, 13 squared minus 12 squared, all times pi. And then we set that equal to pi r squared. 25 was equal to r squared, we got r. Fairly straightforward question. Really, the only trick to it was remembering the formula for the area of a circle. But a good, nice, clean introductory question. And yeah, I think we're off to a good start on the 2005. And join me, please, in the next video as we take a look at question number 2, which apparently also has 3 parts. And I think will involve a little game theory. It's always nice to see game theory on a contest, but we'll explore that next time.